Alex added the page numbers of a book together, and got a total of 888. Okay, what a complete waste of time that Alex underwent there. Unfortunately, he didn't notice that one of the sheets of the book was missing. Odd page number on the front and an even page number on the back. Okay, so, and then finally, what is the page number on the final page of the book? Okay, when you're adding up the page numbers of a book, the sum looks like this. 1 plus 2 plus 3 plus ... n minus 1 plus n, right? We have seen that before. That's a triangular number. And we know that whatever Alex did, he got 888. But we've got to add a little bit more. We've got to add the parts that he was missing. Let's just call it x and x plus 1. And we know that if the odd page number is on the front, that's the smaller one. So we know this one right here needs to be odd, and this one needs to be even. We could write that even more carefully with like 2x minus 1 and 2x, but it's fine for right now. Okay, and because we're genius math calc students, we know that this sum is n times n plus 1 over 2. One way to do that is to know that the average is n plus 1 over 2, and I get that from any pair of numbers from the front and the back, etc., etc. Okay, so n times n plus 1 over 2 equals 888 plus 2x plus 1. Okay, now we kind of just need to pick some big triangular numbers and see which ones work.
Okay.
Because it's possible that we have a triangular number and like maybe x doesn't turn out to be an integer, so we know like that one wouldn't work. But now this is sort of like n squared over 2. Okay, so like I know that if n was 40, right, then I would get like 1600 over 2. So I need to pick numbers that are bigger than 40, because this number is bigger than 800.
Okay, then let's start with 45.
That's too big. I was going to start with 41.
Okay.
Okay, so 41 times 42 over 2 is 41 times 21. We worked that out in our spare time, and we got 861. Okay? That is too small. Okay? How do we get the next bigger triangular number? Remember, this was n times n plus 1 over 2. In other words, n was 41. So to get the next...
Make n 42.
Or we could just add 42 to 861.
Well,
right?
true,
because that's how we get the next one.
Big.
903. Now, it does turn out that this is also 42 times 43 over 2. But I'm saying that's how you get the next triangular number.
Okay.
Okay, now, 903, let's test it out. 888 plus 2x plus 1. Feel free to hit pause and solve this equation. You get x equals 7. In other words, this x plus 1.
Where's the equation?
Right here. This equation.
Oh, okay. I thought it was just that.
No, I'm going fast here because you can always hit pause on the videos, and you have like the sheet of paper that goes over it. Anyway, if 7 is x, this x times x plus 1 was 7 plus 8. Let's just go back up here and check. We needed odd and then even, so that works out. So the page numbers that are missing are 7 and 8. That's not the question. The question is, what's the last page number in the book? And that's n. Right? So, ultimately, what do we know? We know that 1 plus 2 plus all the way out to 41 plus 42 is 888 plus 7 plus 8. And this is like the entire equation of the problem written out, totally solved. These are the 2 pages that were missing. This is the sum that he got in real life, and this is the triangular number that he would have gotten if he'd added it up right. Okay.